Some dates just feel random. April 15th, for example. But what if I told you that in the world of math, this one day is actually kind of a huge deal? Yeah, it's pretty special. Let's dive into why. It's wild, but it turns out that on this exact date, across totally different eras and all over the globe, a few absolute geniuses were born or died, and in doing so, they literally shaped the world we're living in right now. And all of their incredible stories link back to this one day. So, let's meet these amazing minds one by one. Okay, let's start with something you probably did today. Ever wonder how you can binge watch your favorite show and it just streams perfectly? No annoying buffering wheel, no lag, even though millions of other people are doing the exact same thing at the exact same time? How does the internet even handle all that? Well, the answer, or at least a big part of it, starts on April 15th, 1932. That's the day a Welsh mathematician named John Lewis was born. So, Lewis worked with this really cool field of math called Large Deviation Theory. Sounds intense, right? But it's basically the science of predicting super rare, out-of-the-blue events. He applied this idea to internet traffic. See, instead of just guessing when a massive data spike might happen, he figured out a way to mathematically calculate the probability of it happening. And that was a game changer. It let engineers build smarter networks that could actually anticipate and handle those huge surges, which is what keeps everything running so smoothly for us. So, yeah, the reason your favorite show doesn't buffer, it's not some kind of internet magic. It's just really, really good math. All right, that's our first pin on the timeline. Now we're going to stick with April 15th, but let's jump forward in time to a totally different area of science. Okay, let's switch gears. Think about this. How does a tiny little seed know how to grow into this huge, complex plant? Or even crazier, how do our own bodies build themselves from just a few cells? What's the hidden code driving all of it? You guessed it, our search for that answer brings us right back to April 15th. On this day in 2018, an American biophysicist named George Oster passed away, and he left behind this incredible legacy of trying to decode that very blueprint of life. Oster was a pioneer. He used mathematical models to figure out some of biology's toughest puzzles. He'd look at all the beautiful, chaotic stuff happening in nature. I'm talking about everything from molecules dancing around inside a cell to how entire populations of animals grow and shrink. And he translated it all into the language of equations. He was literally using math to find the hidden rulebook for life itself. I love this way of putting it. He saw the universe of life not just through a microscope, but through an equation. So now, this one date, April 15th, connects the digital networks that power our phones to the biological networks that power life itself. How cool is that? Let's add them to our timeline. All right, here's another one for you. Picture a spinning top. It's perfectly stable. And then, suddenly, it's not. It wobbles and collapses. Why? Now think bigger. A bridge, our climate, even the economy. How on earth can we predict if a huge complex system like that is going to hold strong or just fall apart? Well, that exact question was the obsession of a Brazilian mathematician named Maurício Peixoto. And you know when he was born? April 15th, 1921. Peixoto developed something called Peixoto's Theorem, which is basically a mathematical toolkit to see if a system is structurally stable. Here's a simple way to think about it. If you give a stable system a little nudge, it might wobble, but it'll go back to how it was. But if you nudge a fragile system, it could collapse completely. Peixoto gave us the math to tell the difference between the two before disaster strikes. You could say he gave us the math to understand that fine, fine line between order and total chaos. It's amazing, right? One date, so many brilliant stories. And we've got one more stop to make on our April 15th journey. Let's go back to your phone for a second. Every time you pinch to zoom on a photo or rotate it or slap on a filter, you're actually doing math. You're performing something called a transformation. But what are the fundamental rules behind all those changes? To answer that, we have to talk about the Ukrainian mathematician Lazar Gluskin. And yep, he passed away on April 15th, 1985. Okay, so Gluskin was a master of something called semi-group theory. I know, it sounds super complicated, but just think of it as the grammar for actions. He studied the deep, fundamental rules of transformations, the math behind stuff like stretching, shrinking, and rotating things. He basically wrote the rulebook that now powers everything from the filters on your phone to the most advanced computer graphics. So really, every click, every swipe, every filter you use, it's like your screen is having a little conversation in the language of transformations. And there we have it. John Lewis, George Oster, Maurício Peixoto, and Lazar Gluskin. 4 incredible minds from 4 different parts of the world working on 4 completely different problems. And they're all connected by this one single day, April 15th. But, beyond just sharing a date on the calendar, there's something much deeper connecting them all. It's this profound curiosity. It didn't matter if they were looking at internet traffic, a living cell, a spinning top, or a digital photo, they were all asking the same powerful question. What's the pattern hidden inside all this chaos? And it's because they dared to ask that question that our modern world works the way it does today.